Today we're going to be answering problems involving limit, but this time the functions that will be given to us will be in graph form. So in this particular problem, we have two functions. We have the function f of x, which is represented by the pink graph, including this dot over here, and the function g of x, which is represented by the blue graph right here. Now we have some functions here that we're going to be solving. So all you need to do is to make sure that you know the basic definition of a limit, which means the value of y given x, or as x approaches to a certain constant, what would be the value of your y. Now for the first example, we're working on the limit of f of x, so we're going to be focusing on the pink graph as x approaches negative 2. So as x equals to negative 2, we know this is 0, x equals 0, this is x equals to negative 1, and this is x equals to negative 2. This one will be the values of our y's, and we will use that to evaluate our number in a little while. So at x equals to negative 2, coming from the left and coming from the right, because we have the value of negative 2 right here, we would know that from the right, it's approaching the value of y at negative 1, and from the left, it's approaching the value of y at also positive 1. So for number 1, the limit of f of x as x approaches negative 2 is going to be at positive 1. So that will be problem number 1. And for problem number 2, we're looking for the exact value of y given x is equal to negative 2 for function f, or the pink function. So here we have two options. We have 1 and 2. But of course, we're going to be using this dot over here, because this open circle, it means that the value of y at x equal to negative 2 is undefined. So we will use x equal to positive 2. So number 2 is 2. Now for number 3, it's a limit again at x equal to negative 2, but this time the function is g of x. So you will ignore the pink graph and you will be focusing on the blue graph. And on the blue graph, from the right and from the left, it's approaching the same value of y, which is equal to negative 1. So that means number 3, will give you negative 1. And for problem number 4, it's g of x given x is at negative 2. This is x at negative 2. What is the exact value of your value of y of your function g? And this one, you have no other choice but this value right here at negative 1, and it exists because there's no hole right here. So this one will be negative 1. And for number 5, we're looking for a one-sided limit. So this plus sign right here doesn't mean 1 should be positive. It means the value of g of x as x approaches 1 from the right. So this is the positive side. So if you're going to use x equal to 1, this is 1. Coming from the positive side, going to x equal to positive 1, the value of y is going to be approximately equal to negative 1. So this one is equal to negative 1 coming from the right. And you will notice that coming from the left, the value of y will be different. Therefore, coming from the left, which is problem number 6, what will be the value of y? It will be equal to negative 2. So the value of y is negative 2 as x approaches positive 1 from the left for a specific function g of x. And for number 7, we're looking for g of 1 and g of 1 at exactly x equal to 1. Using the value or the blue graph, what is g of 1? It will be negative 2, because negative 2 is a closed circle, and this one is undefined at negative 1. Now, if we're going to find the limit of g of x as x approaches 1, so this time it's no longer a one-sided limit, so this one is x equal to 1, we will notice that from the right, it's negative 1, and from the left, it's negative 2. So it's not connecting, so that means the limit of the function at x equal to 1 for g of x is DNE or does not exist. So this is how we answer problem of limit function given a graph. So let's have some other example for this problem. Let's answer some of these examples. So let's start with the first graph. We only have one set of function, which is f of x. And in this function, we're going to solve problems 1 through 5. At x equal to 0, what will be the limit of the function? So x equal to 0, you will notice that from the right and from the left, the value of y is not changing, and it's going to be at 3. So the limit is equal to 3 for the first problem. Now for the second problem, this is a one-sided limit. So at x equal to 3, which is right here, what is the value of f of x as x approaches 3 from the left? So from the left, the value of the limit is approaching this value of y right here, which is at 4. And for 3, from the positive side, which is denoted by this symbol right here, so you will see that it's approaching the certain value of y, which is at 2. Now, if we're going to evaluate the limit of f of x at 3 from the left and from the right, we know that it does not exist because it's approaching or going on a different direction. And for the last problem, at f of 3, so f of 3 is right here. What will be the value of y at f equal to 3? And this will be 3. So this is how we're going to answer the first set of problems. Now let's move on to the second function. So we have a different graph and different sets of questions right here. We'll start at limit of f of x as x approaching 1 from the left. So this is 1. Coming from the left, it's approaching positive 2. So this will be your answer because it's a one-sided limit. You don't care about the other side of the function at x equal to 1. At x equal to 1 from the right, which is positive right here. So from the positive direction, the value of the function is approximately at x equal to, or y equal to 3. So therefore, since from the left and from the right, the function is approaching a different number, so we know that for number 8, at x equal to 1, the limit does not exist because they're not connected. And for number 9, limit of f of x as x approaches 5, this is 5, so since we are looking for the limit and not the exact value of y at x equal to 5, we know that that is approaching from the left and from the left and from the right, it's approaching this value, which is equal to 4. So the limit of the function exists at number 9, and for number 10, at exactly x equal to 5, what is y? And here, it's a whole, so that means at f of 5, y is undefined. So the function is undefined at exactly f equal to 5. And that's how the second set of problems are solved. Now for the last one, we're looking for one-sided limit again. So for the first question, we need to find the value of f of x as x approaches 2 from the right. So from the right, going here, we know that the function is going down to the negative infinity. So this one is negative infinity. And for the other side of the function, at x equal to 2, from the right, it's approaching the value that is going higher and higher, so this one is positive infinity. Because in this particular function, this one shows a behavior of a rational function with a vertical asymptote, so we know that the vertical asymptote of f of x is at x equal to 2. And that is how we answer problems involving limit and the graph of the function.